Sketch the graph of r of x equals x minus 1 over x squared minus 2x. Now, sketching the graph of a rational function, there's a lot of different steps. So we're just going to get started here with the domain. Okay, so the domain we're going to find by factoring completely. So we've got x minus 1 over, we can factor an x out of that denominator, x times x minus 2. And that tells us that these two factors in the denominator cannot be 0 because we can't divide by 0. So our domain is the set of all real numbers, okay, such that x is not 0 and x is not 2. So x not equal to 0, x not equal to 2. Okay. That's our domain. The next thing we're going to do is reduce the fraction. Okay, and so that's here. We've got our factored form, x minus 1 over x times x minus 2. There are no common factors here. So that is the reduced form. Okay, next thing is any wholes. Okay, we only get wholes if our reduced form, if we've changed our domain by looking at our reduced form. Okay, and our domain here is of course the same as the original because nothing happened. It was already in reduced form, so there are no wholes. Next thing we're going to do is look at vertical asymptotes. So our vertical asymptotes is just the zeros of the denominator, okay, those numbers that were pulled out of the domain, if they're not wholes. Okay, now nothing reduced. We just look at this denominator and we get the zeros of that, x equals 0 and x equals 2. Those are the two zeros of our denominator. So those are the vertical asymptotes. Vertical asymptotes. Next is intercepts. Okay, and so that's well, the y-intercept we get by just plugging 0 into the function. Now the problem is 0 is not in the domain. Okay, so r of 0 is what we would do, but this is undefined. And because it's undefined, there is no y-intercept. Okay. No y-intercept. For our x-intercept, all we do is we take the zeros of the numerator. So we have x minus 1, and the 0 there is x equals 1. Okay? And so our x-intercept has a y value, or x value of 1. Of course, y value is 0. So 1, 0 is the x-intercept. Okay, our next step is horizontal asymptotes. Horizontal asymptotes. For rational functions, you'll actually never have more than one. So just horizontal asymptote. And this is where we compare the degree of the numerator and the degree of the denominator. The degree of the numerator here is 1. The degree of the denominator is 2. When the denominator has a larger exponent, okay, higher degree, that means that y equals 0 is our y-intercept, or our horizontal asymptote. Now, with all of this information, we're ready to put it all together. And we start by just drawing what we know. So we don't have any wholes, but we do have some vertical asymptotes. So we'll go ahead and do that. We've got one at 0, which is, of course, just the y-axis. And we've got x equals 2. So 1, 2. And there's our, those are our vertical asymptotes. There's no y-intercept, of course, because we have a vertical asymptote there. But we do have an x-intercept at 1, 1, 0. And so we can plot that. That's this point right here. And then finally we have a horizontal asymptote at y equals 0. That is the x-axis. All right, so now we have to actually draw something. And we don't actually really have very much information here. So what I like to do is look at these in sections. Okay, I've got 3 sections. I've got to the left of this asymptote, between the two asymptotes, and to the right of the this asymptote. And so what we need is just kind of a starting point. And so you just plug in a random number. Okay, I'm going to plug in -1. All right, it's going to give me a point over here. It's going to tell me if I'm up here or down here. Okay, so if I plug -1 into this function, okay, r of, let's use r of -1, I get a -2 on top over a 1 plus 2, which is 3. I get a -2/3. So that at -1, that tells me I'm down, right around here. That gives me a point. Now, I am not allowed to cross the x-axis anywhere except for at this intercept. That tells me that I'm going to just approach my horizontal asymptote and I can't cross it. Okay, and then I have to follow my vertical asymptote, and I can't turn around and go up because that would make me cross the x-axis here. So I have to go down. Okay, then we need to know what's going on here. Now there's a couple of different things to know. First of all, around an asymptote, we can know the behavior if we've got the same behavior on either side, meaning on the left I'm going down. I can know if I'm going down on the right or if I'm going up. Okay, and that all comes from where this asymptote came from. This asymptote came from this x right here. Okay, and you look at the exponent on the factor that gave you the asymptote. The exponent here is 1, okay, which is an odd number. And if it's odd, that means that the behavior around the asymptote is different on the left and on the right. So on the left, it's going down. On the right of this asymptote, we need to be going up. Okay. And then I come down to this point. Now, what happens at this point? I could bounce off of it, okay, or I could cross through it. And the way we determine that is we look at where that came from. And that came from x minus 1, which, again, we look at the exponent. An odd exponent means we're going to cross the axis, and even means we're going to bounce off of it. And even more than that, it means we're going to look like that type of function. So it looks like x to the 1, which is a line. If this was x minus 1 cubed, it would look like a cubic. So it would kind of flatten and then drop down. But this is to the 1. That's just a linear function, so it just kind of looks like a line crossing through. And I can't turn around. I've got to follow my vertical asymptote, but I can't turn around and come up because I would have to cross the axis again to do that. So it has to go down like that. And then finally, at x equals 2, again, I look at the behavior around the asymptote. That comes from this x minus 2, which has an exponent of 1, which is odd. And so the behavior of the function on either side is different. So if it's going down on the left of this asymptote, that means it's going up on the right of the asymptote. And then I have to follow my horizontal asymptote. And so just follow it. I can't cross the axis because I don't have any more x-intercepts. And so there is the sketch of my rational function. Now, if you want to, instead of looking at behavior, you can just plug in a few points. Okay, we got this one pretty easily. We could plug in, a point between 0 and 1 and between 1 and 2 to know that we're above the axis here and below the axis here. And we could have plugged in a value bigger than 2 to find out that we're above the axis. And it's really up to you. But I like using the exponents and knowing kind of the behavior around my asymptotes and my intercepts. I think it's important to kind of have an understanding of what's going on in the actual function.